Greetings to sir. I'm Sivaswashni Ulaganathan. My matrix number is V08155 and I'll be explaining about the part result and discussion for the lab 5. So moving on to the first question, predict the properties of a wave. So what are the properties of the wave? We have 5. First is the wavelength, second is the frequency, third is speed or velocity of a wave, fourth is the amplitude, and fifth is the time period. Moving on to the second question. Compare and contrast the behavior of a wave with different damping, tension, and end conditions. So, for the first, we have to write about damping. So, a damped wave is a wave whose oscillation amplitude decreases over time, gradually going to zero, a sinusoidal wave that decays exponentially. The greater the damping, the more quickly the waves decay and ultimately return to zero. Then, the shorter the damping, the slower the decay of the waves, and number 4, the wave would not return to zero if there is no damping. Then, moving on to the tension. So, when the voltage is higher, the speed of the waves was slightly higher, although the frequency did not impact the wave speed. Second is the waves will fly at higher velocities across tighter ropes. Third one is slower waves moves through the looser ropes. Then moving on to the end condition, we have three ends. So first is the loose end. If a crest wave moves towards the loose end, a crest wave with the same magnitude will bounce back, assume the damping does not occur. Second is the fixed end, so it transforms itself into a trough wave as a crest wave heads towards the fixed end and bounces back. Number 3 is the no end. Since the end is infinite, the wave produced will pass continuously without interruption, therefore a wave does not bounce back. So that's all from me. Thank you, sir, and I'll be passing to my groupmates. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good day. My name is Muhammad Yusuf Erian Solium Sufi and my meeting number is B081910202 and I am from class DZ1/2. Okay, this is lab 5. So in this lab, I want to present about this part and this part. So this is amplitude. High amplitude wave carries a large amount of energy while low amplitude wave carries a small amount of energy. Besides, the amplitude of a wave is normally defined as the maximum displacement of the particle within the waveform their normal equilibrium position. The situation when the force and bulk acting on a part of the body balance. So in the frequency is measured in hertz wave per second. When frequency increase, more wave creates past a fixed point each second. That means the wavelength shortens. So as frequency increase, wavelength decrease. So in the period when we increase the frequency, then the period will shorten and will decrease the frequency. The period will longest. So next, so how a wave travel indefinitely in free space. The wave never lose energy. There is no alteration in the amplitude of the wave, and thus they keep traveling infinitely when there is oscillation. Electromagnetic wave is energy that travels space, which is a light, is existing everywhere in the universe. It oscillates when energy disturbs it, just like the road move up and down when someone sick. But unlike other waves that exist in the water and sound wave, light wave does not need any physical substance to travel, so they can cross space indefinitely. So this is the simulation in this part. You can see here. So this is a simulation for wave on a string. So we can play. Okay, this is a for amplitude setting, and this is a frequency setting. and then this is a damping, and then this is a tension. We take the rollers to measure the length, and then we put the oscillate, and then this is a no end. As you can see here, if we adjust the amplitude height, so that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. This is Saiful Hasbullah bin Muhammad. In this last slide, I will explain the electromagnetic waves. For the first step is the objective of this lab to discover and understand wave properties and behavior. Next, to predict the behavior of waves through varying medium and reflective endpoints. Okay. Next, understanding standard waves. Okay. For the procedure on this lab is first that we need to click the link given in left sheet, and after that the icon of the simulation will display on our desktop, so we can press the play button to start the simulation. Okay, for the step 3 is we need to determine the properties of waves, which are frequency, amplitude, wavelength, and speed. Okay, so we need to click the icon on the simulation, which is instruction that we need to do. Okay. After that, for my step is after that calculate and demonstrate the standard wave. Okay, this is the simulation, and I choose with and the oscillate. Okay. And on the simulation I get the timer is 9.65 seconds. Okay. This is the frequency of the calculation. Okay. Frequency is F, which is 1 per C. C equals 0.965. Okay, so frequency equals 1 per 0.965, and we get 0.10 Hz. Okay, for the wavelength, lambda equals C for F, where C equals 3 times 10 power of 8. Okay, so 3 times 10 power of 8 equals 0.10 Hz. Okay, and we get 3.00 times 10 power of 8. Okay. For the conclusion on this lab is based on this lab, we able to identify and understand the wave property and behavior. Next, we able to predict the behavior of wave through varying medium and reflective endpoints. Okay, lastly, we understand how to find and the wave manage to compare between traverse waves and plug into the waveform the lab that we have very much. Okay, that's all for me. Thank you, sir.